Here's some more examples of fractals that we could study. 2D on paper fractals are not the only ones. There are 3D fractals too. So let's say I started with a solid cube, and this will be the rule that I follow. Every time I see a cube, I'm going to slice it into 27 identical mini cubes. So that means that I'm slicing in every dimension, I'm slicing twice. I'm slicing into thirds. So imagine that you have 3 layers of 9 cubes each. That's how you get 27. Now what I'm going to do is I'm going to keep the cubes that touch an edge of the original cube, and I'm going to throw out the rest. I get this center picture here. I wind up throwing out 7 cubes. And that's hard to see here, but remember from chapter 4 that the cube has 6 faces, right? And so there's actually that one middle cube from all 6 faces is being removed. And then there was a cube that was in the very, very center of the big cube that wasn't actually on the outside at all. It was the interior cube, and that's going to be deleted as well. So that's 7 that I'm throwing out, which means there's 20 mini cubes in the center picture. I have to follow this rule again to get the picture on the right. I'm going to follow the rule 20 times for the 20 green cubes that remain. I take all of those 20 cubes, I slice them into 20 grandbaby cubes, mini cubes, and then I throw out the same 7 mini cubes in the same pattern. And so I get this beautiful pattern on the right here. If we were to do our counting, it's going to be exponential again. So 20 to the 0 is 1. 20 to the 1 is 20. That's how many cubes are in the middle picture. 20 to the 2 power is 400. So that's how many mini cubes are in the right-hand picture. And so that thing gets fancier and fancier with more and more tiny cubes as we go through stages. And the full infinite Menger sponge has infinitely many, infinitely small cubes. The next example is one that's actually kind of familiar to you guys. It's the golden spiral. This is a legit fractal. So here's the process. If I were to reframe golden spirals in a fractally way, this is what I would say. You start with a golden rectangle. We know what those are. And you remember that property that these guys have. If you cut off a square, then what's left over is a smaller golden rectangle. That was a really big deal back when we were studying golden rectangles in 4.3. And so then what you do is you draw a quarter circle in the square that you cut off. And you repeat forever. So first you cut off this square and draw a quarter circle inside of it. And then what's left on the right is a golden rectangle. And then you're supposed to cut off a square and draw a quarter circle in it. And what's left is a golden rectangle. And you actually repeat that infinitely many times. And we did mention that the golden spiral goes around infinitely many times. Here's another way that we can think about it. Do you see this shape right here? This actually literally is a complete, beautiful, infinitely spiraling golden spiral. So this is a golden spiral inside of this golden spiral. This is also a golden spiral inside of this golden spiral. And so is this, and so is this, and so is this, and so is this. And so the golden spiral contains an actual complete copy of itself. You could zoom in forever and you would never stop seeing golden spirals. Related to that is the golden ratio. Now, way back in the beginning of the class, when I tried to explain what the golden ratio was, it's like literally the number 1 plus radical 5 over 2, or it's like 1.6. But how did we figure out what that was? We actually did fractions of Fibonacci numbers, but then what happened was we expressed those fractions as repeated fractions. As fractions that looked like 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over, on and on and on. And so if I were talking about the golden ratio as a fractal, I would say, begin with the fraction 1 plus 1 over 1. Then, the rule that I'll repeat infinitely many times is, every time you see a 1 all by itself in a denominator, you will replace it with 1 plus 1 over 1. Which means from stage to stage, you're only ever replacing one thing, which means there's only ever going to be one more fraction bar. So here I have the second stage. I took this 1 and I replaced it with the fraction 1 plus 1 over 1, or the expression. Then I took this 1 and replaced it with this expression. And then I took this one and replaced it with this expression. And so it goes forever and ever. You have this infinite compound fraction that actually contains itself. This is the golden ratio. This is the golden ratio. This is the golden ratio. It never stops. And so this is a legit fractal that's made out of algebra, actually. And it's equal to 1 plus radical 5 over 2.